Hey guys, here's the spiral view for spiral 9. We're going to start off with some beyond the unit circle, not behind the unit circle, trig stuff. First off, I've got to figure out some of these values. So we've got cosine squared 11 pi over 3. That means I've got to figure out cosine of 11 pi over 3 first. Cosine of 11 pi over 3, first thing I need to do is figure out where that is. So I know that this is going to be just a little bit less than 4 pi, because this is going to be 3 2/3 pi. So that would be 1, 2, 3 pi, and then 2/3 of the way the next one is going to be down here. So we are in quadrant 4. Okay. I also know this is going to be the 60-degree value, so for cosine that would be a half. And in this quadrant, that'd be positive, okay? I've also got sine of this value I got to find, so I'll do that now while I have this being thought of. So sine here is going to be the negative square root of 3 over 2. Negative because we're in quadrant 4, and because we're at a pi over 3 family, we're looking at the square root of 3 over 2. Okay? And then I've got to find tangent of pi. That's going to be right there. My coordinates there are -1, 0. Tangent is the y divided by the x, or 0 over 1, which is 0. Okay, let's plug these things in. First up, we've got a half. That's going to be squared. Then we've got 0, and that's going to be squared. And then we've got the square root of 3 over 2, and that's squared also. Again, I'd like you to notice that we found the trig values for each of these things, and now we're plugging them in, and now we're squaring them. So that's going to be 1/4 plus 0. And then the square root of 3 over 2 squared is going to be 3 on top and 4 on the bottom. 1/4 plus 3/4 is going to be 1. Second problem in the section, we're looking at sine of m is -5 over 6. And cosine of m is greater than 0. Okay, let's figure out where this is. First, I'm going to use the fact that this is negative for sine and positive for cosine. That only happens in the fourth quadrant. So just to be aware of what's going on there. Okay, next thing's next. Let's make a triangle where the opposite of my angle, sorry, that's going to be angle M, is going to be 5, and my hypotenuse is going to be 6. To find my third side, we're going to do 6 squared is equal to 5 squared plus x squared. So 36 is equal to 25 plus x squared. That means that 11 is x squared, and the square root of 11 is going to be the length of that side. Okay, tangent is going to be, so tangent of m is going to be 5 over 11. We're down in the fourth quadrant, so that should be -5 over 11. Tangent squared of m is going to be -5 over, square root of 11 squared, which is going to be positive 25. And square root of 11 squared is going to be 11. That's my final answer. Let's graph some trig functions. First off, we've got 3 sine of 2 theta minus pi over 4 minus 1. First things first, let's draw my midline at -1. And I'm going to use my amplitude just to get an idea that I should be going up to this line at +2, down to this line at -4, just to get an idea where this thing is going to be focused. Okay, I know that sine has 3 points on the midline. So let's find that first one by saying 2 theta minus pi over 4 is going to be 0. All right, I'm going to add pi over 4 to both sides. So 2 theta is equal to pi over 4. And I'm going to divide both sides by 2. And a quarter divided by 2 is going to be 1/8. So that theta is equal to pi over 8. Just for the sake of easiness, I'm going to mark this first place as pi over 8. So that's my starting value. Okay, let's get an ending value. So I did that for 0. Now I'm going to do the same thing for 2 pi. 2 theta minus pi over 4 is equal to 2 pi. Let us add pi over 4 to both sides. So 2 theta is equal to 2 pi. I'm going to write that as 8 pi over 4 because I know I need a common denominator. So we've got 8 pi divided by 4. And to that, we're going to add 1 pi over 4. That's 9 pi over 4. When I go to divide that by 2, I end up getting that theta, and dividing by 2 is the same as multiplying by a half. It's going to be 9 pi over 8. Okay, I know that I can break a trig function up into 4 pieces, so I'm going to count until I get to my 4th spot. So that's 1, 2, 3, 4. And I'm going to call that 9 pi over 8. All right, halfway between these two is going to be 5 pi over 8. And if I wanted to, that would be 3 pi over 8 between 1 and 3. And then we'd have 7 pi over 8 between 5 and 9. And this 9 should really be here. But I started writing that too soon. Okay, so my other ending point gives me that value on my midline. Exactly in the middle, I've got another point there. And since this is sine, we've got a positive value. I'm going to go to my 2 middle things. First, I'm going to go up to my amplitude, and then I'm going to go down to my amplitude. This graph should look something like this. Next up, we've got y equals 1/2 cosine of 1/3 theta plus 3 over 2. Okay, I don't love that we're dealing in terms of halves here, so maybe I'll make my y-axis a half. That's 1, and this would be 3 halves. And that'd be negative a half down here, just to make this a little bit easier to graph. All right, my midline is going to be up here. And if I want to draw in my amplitude values, I've got to go a half above and a half below this, just to kind of get the neighborhood that my function exists inside of. We know that cosine starts at the top, goes down to the bottom, starts back at the top again. This is positive, so it's going to follow that shape. To get my endpoints, I'm going to set the inside equal to 0 and inside equal to 2 pi. So for the first one, 1/3 theta is equal to 0. If I divide both sides by 1/3 or multiply them by 3, I get theta is equal to 0. Okay, so that's going to be at the top at 0. All right. Next point, 1/3 theta is equal to 2 pi. If I multiply by 3 to get rid of that 1/3, I get that theta is equal to 6 pi. And just like before, I'm going to count over 4 spaces, so 1, 2, 3, 4, and I could make that 6 pi. If you wanted to stretch this out more just to see it a little bit clearer, you could go count 2 spaces for each one, so that would be 2, 3, 4, and have that be your 6 pi. That means halfway in there would be 3 pi, and then you'd have 1.5 pi and 4.5 pi in between those two. Okay, I know that cosine ends at the top again, so there's my second point. The middle one is going to be down at the bottom, and then halfway between there we get our midline points. So it's going to look something like this. And again, if you put your points closer together, it's going to be squishier, but that's okay. Next up, we've got to find an equation for this graph. We're going to use both sine and cosine. And to do that, we have to get some information out of here. First thing I might want to find is the midline. That's not going to change between sine and cosine. And if I know that I'm going from -2 up to 4, halfway between those values is going to be a value of 1. Okay. I also probably should get my amplitude, and my amplitude going from 1 up to 4 is going to be a value of 3. All right, period. And looking at this, I'm going to count from the top to the top. From negative 1.5 to 5.5 is going to be 7. To solve for b, I'm going to say that 2 pi over b is equal to 7. In other words, my b value is going to be 2 pi over 7. Okay? I've got midline, I've got amplitude, I've got period. Now I've got to think about what my sine and cosine values are going to be. Okay. First of all, I need to find a cosine equation because I've got a max, and that's easy to find. So that means that for cosine, we're starting at a positive cosine, and this is going to be a c value of negative 1.5. Okay, that equation is going to look like y equals 3 cosine 2 pi over 7 x minus negative 1.5, or x plus 1.5, and then plus 1 at the end. Then I can try to find a sine value. And I can't quite see what that point is. We know sine starts at our midline. In trying to find out what this sine value is, maybe look halfway between 2 and 5.5. Ugh. So that means that for a positive sine graph, 2 plus 5.5 is going to be 7.5, and halfway there is going to be 3.75. I don't love that, but that's the best I can do based on the points that I so kindly gave you. That might look like y is equal to 3 sine of 2 pi over 7 times the quantity x minus 3.75, and that's plus 1. You're welcome for that lovely number. Next up, we've got some modeling with trig, and I'm trying to use the table and the graph to create a reasonable model for the relationship below, which looks kind of weird if I take a look at this. So some of the things I could do would be maybe find the midline first, and I take a look at my highest value. That appears to be 7. I'm going to take a look at my lowest value. That appears to be 3. Halfway between those two would be 5. We do the same thing for amplitude. If I go from 5 up to 7, that's going to be 2, and I'd like to notice that if I go from 3 down to, or 3 up to the midline 5, that's also 2. All right, so period, I don't have 2 max values. I do have 2 minimum values at 3 and 3. So if I go from 3.75 minus negative 1.25, I get 5. All right, so if 2 pi over b is equal to 5, that means that my b value is going to be 2 pi over 5. Okay. For cosine, we start at a max value, so that means that for a positive cosine, my c equals 1.25. And in looking at this, we get y is equal to amplitude of 2, cosine, and I'm going to have 2 pi over 5, x minus 1.25, and then plus my midline of 5. If I want to use a sine value, I'm trying to find a value on my midline that appears to happen at 0. That's kind of nice, and that's going up here, so that's going to be a positive sign. So that'd be y is equal to 2 sine 2 pi over 5 x minus 0 plus 5. Here we're looking at some trig equations and setting this up. First thing I have to do is get each trig function by itself. So for example, for 12 tangent theta is equal to negative 4 square root of 3. First thing I might do is divide both sides by 12. And I end up with tangent of theta is equal to the negative square root of 3 over 3 after I reduce 4/12 to 1/3. In terms of this, I got to figure out which trig function is the square root of 3 over 3. So I'm going to draw a couple triangles that I know involve square roots of 3. It's going to be a 30, 60, 90. It should be a half and root 3 over 2. And I've got to figure out which way, if I divide, I get this answer. I'll start with dividing tangent of 30. So we get 1/2 over the square root of 3 over 2, which is the same as 1/2 multiplied by 2 over the square root of 3. And when I cancel my 2's out, I've got 1 over the square root of 3, which I could rationalize the denominator, multiplied by root 3 over 3. And if I take a look at that, I get the square root of 3, and then square root of 3 times square root of 3 is square root of 9. Square root of 9 is 3. Okay. We know we're in the 30-degree family. We know this is negative. So if I take a look at my unit circle, we know that tangent is going to be negative in the second quadrant and in the fourth quadrant. So we're looking at the 30-degree angles in these two quadrants. That's going to be 5 pi over 6, and that's going to be 11 pi over 6. Since we're looking between 0 and 2 pi, those are the only two that I need to do. Just as a reminder, the way that we did this was we started out by looking at this value, and from here we figured out which triangle to use. It happened to be that I guessed on the first try that the 30-degree angle would give me my dividing that ended up with the square root of 3 over 3. From there we looked at our sine. We had a negative value, so we had to use those quadrants, and those were the 30-degree angles within those quadrants. Okay, next up we've got 2 plus cosine theta is equal to 4 plus the square root of 3 over 2. Okay, I think I'm going to just divide this stuff on the right first, see if that simplifies things. So you've got 2 plus cosine theta is equal to 4 divided by 2 is 2, and then square root of 3 over 2 is the square root of 3 over 2. Okay, I get the cosine by itself, minus 2 minus 2. Cosine theta is equal to the square root of 3 over 2. Again, we're looking at a 30, 60, 90 right triangle. For cosine, we're dealing with the 30. That would give us an adjacent of the square root of 3 over 2. So we're looking at 30-degree reference angles. Okay? Between 0 and 2 pi, cosine is going to be positive in the first and the fourth quadrants. So we're looking at angles of pi over 6. That's one of my solutions. And 11 pi over 6. That's my second solution. Again, we tried to get the cosine part by itself. We found a trig value, square root of 3 over 2. We figured out what triangle that's associated with and what angle we should be looking at, and then we figured out what quadrants based on this being a positive value.